let's talk about factoring polynomials. Well, first off, what does it mean to factor? What does it mean to factor? Well, in a sense, it's like you say, what are the factors of the number 12? Well, what numbers go into 12? That's all it is. Probably when you're a little kid, you did greatest common factor. Remember that? GCF, right? GCF, LCD, LED, or whatever. All right, AFL-CIO. You know, it's just that we have factoring. You know, we do these factor trees where you go like this, and then it's like what two numbers? 4 times 3, and then you can say 4 can break down in 2s. Remember these? So this is factoring trees. This is the same thing. We're going to be factoring polynomials. Okay? Factoring polynomials. So as I just factored the number 12, now I'm going to factor. This is an expression, right? Remember, no equal symbol. It's an expression. Is this a polynomial?
Yes.
Why? It's the difference of monomials. That's it. It's the difference of monomials. How is x squared a monomial?
Because it's a product.
Very good. Very good, Paul. X times x. So that's the product of two variables. Okay. All right, so x squared minus x is, we call it binomial. Why?
There are two.
Because there's two of them. Right. And if we had x squared minus x plus 1, what is that? Take a guess. If I said that's a binomial.
Well, that's got to be a polynomial.
Well, it is a polynomial. But if I said this is what type of polynomial, I should say? We said
That's
this is
a binomial.
This is
that would be a trinomial.
There you go. Excellent. Very good, Dave. So trinomial. And we can go on and on and on forever with this. But let's just say, let's go back to this one. X squared minus x is our binomial because it has two terms, two monomials. It's a polynomial. Okay? It's the product of two variables minus just one variable. And remember, guys, we don't put 1 in front of the variables as a coefficients because that's not necessary using Occam's razor applied to math. So x squared minus x, we can factor this out. When we factored 12 over there, we asked ourselves what numbers go into 12. We picked 4 and 3, and then when we broke it down even further, we said what numbers go into 4? 2 and 2. Okay? So we're going to do the same approach to this when we factor polynomial. X squared minus x. What goes into both of these? That's what we're asking ourselves. What goes into both of those?
X.
That's good, x. So if we put x here, and we say how many times does x go into x squared? Goes in 1, so we put x there, and x minus x. I'm just going to explain this. I just wrote it out. I'm going to explain what I did there. I factored out an x. Just as when we did the 12, you can factor out a 4, which leaves a 3. So when I factored out an x, it left an x. When I factored out an x over here, it left a 1. So let's just go, I'm going to actually multiply the x through to show how I factored this out. I'm going to do what is called the distributive property. This is something that's fundamental. Distributive property. Anyone ever heard of that?
Many years ago.
Yeah. So distribute, what does it mean to distribute? To pass out, to hand out, or to disseminate, you know. But distributive property is something which is a fundamental concept in algebra that you just use time and time again, and it's really helpful. I'm going to give another example. We're going to get back to that factoring one to show that works. So we have distributive property. Generally use it with parentheses. There's obviously two ways you can do this. We use please excuse my dear Aunt Sally. We're adding within the parentheses first. 2 plus 1 is 3, and then multiplying by 3, and the answer is 9. Or we can use a distributive property and go 3 times 2, which is
6.
Plus 3 times 1.
3.
That's almost kind of like using the matrix thing also in a way. I wonder if those are related. Equals 9. So I'm just going to cross that equals 9. So what we did there is we used the distributive property. We distributed the 3 to both of these two terms. Okay?